Hi, welcome back to another past paper walkthrough. Today we're doing MEI Core 4, June 2011. So let's get right into the section A. First question, express this in partial fractions. So we need to use the partial fraction general equations. So if I have a cubic on bottom with a linear multiplied by another linear, a linear multiplied by a quadratic, then what I need to do is to have a normal number over the linear plus a linear equation over the quadratic, which gives you the expression. And when you multiply both sides by the bracket, the denominator, then you get a times x squared plus 1 plus 2x plus 1 bx plus c equals 1. And if we take x as minus a half, then this bracket will become 0. So it is ax squared plus a equals 1, and x squared is a quarter, so 5 quarters of a is 1, and so a is 4 over 5. So that's our first value. Now we need to equate the coefficients because we can't do much with bx plus c even if we deleted this term, so we need to expand everything. So 4/5 x squared plus 1 plus 2bx squared plus bx plus 2cx plus c equals to 1. And the coefficient for x squared is 4 over 5 plus 2b, which goes to no coefficients, and so 2b is equal to minus 4 over 5, and b is minus 2/5. Now we need to find c, and the most straightforward way is to say that let's equate the function, the numbers without x. So 4/5 times 1 plus just c equal to 1, and therefore c is 1/5, and that's a, b, and c. So the partial fraction will be a, which is 4 over 5, 4 over 5 times 2x plus 1, add b minus 2/5 x plus c, which is 1/5, divide by x squared plus 1. And this expression can be simplified so that 5 is on the denominator instead of on the numerator, so that would be 1 minus 2x over 5x squared plus 1. Question 2, find the first three terms of the binomial expansion of that in ascending powers of x. State the set of value of x which it is valid. So to find the binomial expansion of this, we need to first find it, put it in the form of powers. So this is 1 plus 3x to the power of a third, because this is the cube root. And the general form of binomial expansion is 1 plus k to the power n equals to 1 plus nk plus n times n minus 1 to the divide by 2 factorial k squared, and so on. And we only need the first three terms, so that will be all we need. So in this case, k is equal to 3x and n is equal to a third. And so the expression here is 1 plus a third of 3x plus a third of minus 2/3 over 2 3x squared, and here the 3 cancels, so 1 plus x plus, this is minus 2/9 divided by 2, which is minus 9 times 9x squared, and the 9 cancels, and so it's left with 1 plus x minus x squared, and that is the first three terms. So for this to be valid, k have to be a small number, smaller than 1, and so 3x have to be smaller than 1, the modulus of it have to be smaller than 1, and that would mean that 3x have to be either smaller than positive 1 or it have to be bigger than minus 1. And so x have to be smaller than a third but larger than minus a third, and that should be not equalities. Yes, it's just inequalities, because if it's 1, then this doesn't, the powers don't decline. So yeah, this is the condition required. Question 3, express 2 sine theta minus 3 cos theta in the form of r sine theta minus alpha, where r and alpha are constants to be determined, and alpha is between half pi and 0. So first of all, we should expand this expression so that it is more alike with the left hand side. So sine compound angle is sine theta cos alpha minus sine alpha cos theta in brackets, and so r cos alpha sine theta is equal to 2 sine theta, while r sine alpha cos theta is equal to 3 cos theta. Note that I have taken out the negative signs, and so the cos theta cancels, the sine theta cancels, and we're left with r cos alpha equals 2 and r sine theta, alpha rather, equals 3. So how do we find r? If we square everything on the left and right for both of these, we get r squared cos squared alpha equals to 4 r squared sine squared alpha equals 9, and if we add both of them together we get 13 equals to sine squared alpha plus cos squared alpha times r squared, which this is conveniently 1, so we can just ignore that. And so r is just the square root of 13. And since we know this relationship, we can now say that cosine of alpha is equal to 2 divided by root 13. And so using the calculator we can find alpha. So make sure you're on, well, you can be on degree of radians, but for this question it's given that alpha is in the radians area of 0 and pi over 2. Well, it's between that. So let's set the calculator on radian mode and do a arc cosine of 2 over root 13. That will give us 0.983 radians. And we need to verify that by doing a arc sine of 3 divided by root 13, which is again 0.8273 0.98273. Never mind, I can't speak today. It's 0.982793. So again, it is the same as this angle, so this is the alpha that we're looking for, and therefore that expression is written as root 13 sine of theta minus 0.983 radians. Now write down the greatest value for 1 plus 2 sine theta minus 3 cos theta. The greatest and the smallest of this value is literally the same as 1 plus root 13 sine theta minus 0.983 radians, because we have done so previously. And so because this whole sine expression can either be plus 1 or minus 1 for max and min, so the maximum of that expression will be equal to 1 plus root 13, while the minimum will be 1 minus root 13. And that's it for this part. Question 4 is parametrics. X equals 2 sine theta, y equals cos 2 theta. Find the exact coordinate of the gradient of the curve on the point with parameter theta equals a third pi, and find y in terms of x. So this is a very typical kind of question because it's a chain rule, sort of. So let's find dy by d theta and dx by d theta, then manipulate that to find dy by dx in terms of theta. So dy by d theta is 2 sine 2 theta negative, and dx by d theta is equal to 2 cos theta positive. And to get dy by dx, you divide the top dy by d theta by dx by d theta, so you get dy by dx equals to minus 2 sine 2 theta divided by 2 cos theta, which 2 cancels, so you are left with minus sine 2 theta over cos theta, and note that this is not tangent because they have different angles. And when theta is a third, we know that it is negative of sine 2 pi over 3 divided by cosine pi over 3. And in the calculator, sine of 2 pi over 3 is root 3 over 2. Divide by cosine of pi over 3, which is a half. Dividing by half means multiplying by 2, so that would be negative root 3 as the exact gradient. Now find y in terms of x, that is just rearranging things. So x over 2 is sine theta, and y is equal to cos 2 theta, which using the compound angle formulas or double angle formulas, it is 1 minus 2 sine squared theta, which means that sine squared theta is x over 2 squared, which is 1 minus x squared over 2, and that is probably good enough. And yeah, we're done with this question. Now question 5, solve the equation cosec squared theta equals 1 plus 2 cot theta for angles between 180 degree and negative 180 degree. So change your calculator to degree mode. It's really picky that they decided to do a radian question and follow it up with a degree question, but let's just get on. So let's start from the left hand side. So cosec is 1 over sine squared theta equals 1 plus 2 cot theta, and 1 over sine squared theta is also sine squared theta plus cos squared theta over sine squared theta, and therefore by splitting this fraction up, we get 1 plus cot squared theta equals 1 plus 2 cot theta, and the 1 cancels because we can just subtract 1 on both sides, and 0 equals to cot squared theta minus 2 cot theta, and by factorizing, cot theta is cot theta minus 2 equals to 0, so cot theta is 0, or cot theta is plus 2. And since cot is 1 over tan, theta equals to that, and for this part there is no solution because 1 over anything cannot be 0 unless it is infinite. Well, there is kind of ways of doing that, those values will be the asymptotes. So for safety reason, let's put that in because it might make a difference. So arctangent, never mind, we can't do arctangent, can we? So let's do the graph instead. So this is the tangent graph, this is the asymptote, and also for the negative domain, those are the asymptotes. So this is 180, this is minus 180, and so this is 90 and minus 90 and plus 90. So plus and minus 90 degree are the values that you can get this asymptotic value. And for this one, the second one, which makes a lot more sense, is 2 tan theta equals to 1, which means that tangent theta is a half, and this time we can actually use our calculator because it makes sense. Arctangent of 0.5, a half, is 26.5. 65 degree, or because it's between these two values, there is actually no other, well actually there's one other, which is 180 less than this, so we take 180 off, which is minus 153.43 degree, and just round everything to 3SF for good measures, 26.6, and this is minus 153 degrees. So that's the two answers. Question 6 is volume of revolution. So you have the line y equals 2x squared with a straight line x plus y equals 3, and they meet at point P, 1, 2. So the shaded region is rotated about the y-axis, so vertically, and you need to find in terms of pi the volume. So the important thing to note here is that there are two different regions that you need to do the volume of revolution on. So for the top bit, it is a simple cone, which means we can use the equation given, a third pi r squared h. This is the general formula for a circular cone shape. So the volume of that, in this case, first of all we need to find the height, which is this h. And the h is the y-intercept subtracted by the y value of point P, because this line is horizontal. And the y for this point is 2 because it's given on this point. And the height for the y-intercept of the line x plus y equals 3 is that x is 0, so 0 plus y equals 3, and therefore y is 3. So we know that it is a 3 to 2, which means h equals to 1, and therefore the area or the volume of revolution for that cone part is a third pi r, which is the horizontal length, which is given by point P, 1. So 1 squared times 1, which is just a third pi. So that's part of the question done. Now we need to do the volume of revolution between 2 and 0 for 2x squared dy. Well, the volume of this revolution when you are doing a rotation through the y-axis is that it is a dy integration with the limits on the y-axis. So the max is 2, the min is 0. And this is x squared, pi x squared dy. And pi is just a number, so you can pull that out. X squared we need to calculate, but it's conveniently given as y over 2 equals to x squared. And so it is just a simple integration of pi over 2 y dy. And the limits are 2 and 0, and y integrates to y squared over 2, and we put in the limits. Don't forget the pi over 2, and that would give us 2 squared divided by 2, which is 2, subtract by 0 divided by 2, which is 0, multiplied by pi over 2, which gives us single pi. And now this is the bottom part, and we have a top part, so it is a single pi add a third pi, which will give you a total volume of 4 over 3 pi, and that's the total area, total volume of the revolution. And that's all for section A. And this paper overall is not that difficult. The most difficult bit is probably just the parametric equation, really, because the whole thing is generally really easy as long as you know the methods. And make sure that you know how partial fractions break up, because if you cannot do this well, then it's gonna be quite some easy mark going away. So yeah, that's it for this video. I'll see you on my next one.